So I guess people are still uh, walking in, and it'll take some time. So I'm just going to start. Um, so my name is Ashwin. I'm from this company called ProtoCentral. We are based in India, and we make open source hardware. We've got about 15 employees. We are based in Bangalore. Um, so this is one of our bigger projects, I mean, which we've been running for quite a long time. And I'm here to talk about the HealthyPi. So before that, what is a patient monitor? I mean, my title says patient monitor, right? So when you say patient, it automatically means somebody who's sick. So, um, but that may not be correct. But this is what you typically comes to your mind when you think about patient monitor, and you think of somebody lying in a hospital bed. Um, so what it typically does is measures your vital signs. So we prefer to call it vital signs monitor rather than a patient monitor, because we do deal with sick patients also, but still. Um, so the basic vital signs, ECG, PPG, that is optically from the finger, um, and from PPG you get also SpO2. SpO2 became very popular because of COVID. Everybody wanted a SpO2 monitor. And respiration, which is a signal that is uh, which shows the respiration cycles that a person is going through. If he's short of breath, if the patient is short of breath, then your respiration rate is quite high, right? So typically you want a respiration rate below 20. And then you have body temperature, and there's a whole bunch of other stuff depending on what you're in for. Um, and I'm not going to talk about that. So these are usually in hospitals. And the last point is important. These are very scary looking. I mean, when I see this, I just recollect somebody in the hospital, and I don't want to go there. So, so a project started with this idea: is what if we, I mean, most of the patient monitors that you see in the hospitals are like black boxes, right? So it monitors all this stuff, but you just get to see it. It's locked into proprietary formats, and it is interpreted by doctors and nurses and all that. But most of these patient monitors are also very expensive, so you don't get very good ones that are give good signal for much cheaper. So what we did is we thought, okay, let's democratize this device as well. And to our surprise, we didn't find anyone at that time. This was in 2017. We didn't find anyone at that time who was doing this. So you pretty much have the same vital signs that I spoke about. We made this as a hat for a Raspberry Pi. So most of you must have used a Raspberry Pi. So this sits on the Raspberry Pi, takes the signals, and the Raspberry Pi acts as the host computer. It processes, it can display the stuff. So this is, the screen there is just a standard 7-inch Raspberry Pi screen with an off-the-shelf enclosure. And this is what the board looks like. The white one is the HealthyPi. So the goal here was to use this as a tool for medical research and development, where if you have a black box where you cannot take signals out of, then medical research becomes very difficult. And also developing new generations of devices. And more importantly, it was also a reference design for low-cost settings, especially constrained low-income countries. So these were our major goals. And they don't have to be scary. So we wanted to show this. So this is my At that time, he was 3 years old. He's my 3-year-old nephew. So he asked me what was this PPG. So I showed him PPG. So what you see on the left is a rabbit jumping on the edge of the PPG signal. Right? So he still remembers what PPG means, by the way. He's 10 years old now. And even during COVID, he came and asked me, okay, yeah, I know what PPG means, but does COVID make the rabbit go slower? So, so, so yeah, so they don't have to be scary. So we just put a nice background. If you can see the same thing. So the display unit was running processing, so we could just put pretty much anything on there. And then in 2017, Hackaday happened. We thought, why don't we enter this into the Hackaday prize challenge for 2017? And we did not expect this because at that time it was a pretty primitive device. It was not a finished device at all. But we ended up winning the second prize, which was a pretty big deal for us. And it also brought in about $25,000 of prize money. So we really invested that. And since then, we've been holding on to the HealthyPi platform, still trying to keep it open. We are not, we do sell these kits. All of these are different projects on crowd supply. So the revision 3 was based on a SAM D21 Atmel chip, which is now microchip. And the microcontroller is responsible for capturing the signals from the ADCs. I'm going to skip over a lot of details because the details take time. So I'm just going to, if anybody has any questions, you can talk to me after. So at that time, this was the first open source patient monitor for which we won the prize. Revision 4 was in 2019, where we added Bluetooth support, and it was a standalone device. You don't need a Raspberry Pi anymore. But the name stuck, so we still called it HealthyPi. And it can still work as a hat for Raspberry Pi if you really wanted to. And then COVID-19 happened. So that's where all the chips went out of stock, and then it kind of threw off the entire supply chain. So we had to quickly come up with a revision because during COVID-19, there was a lot of demand for these kind of devices as well. I mean, I remember 2 studies where in one study in a hospital in India, a research lab a government research lab, they wanted to study the vital signs of patients in a COVID ward. So they bought like 25 of these. Since these were not so expensive, they bought 25 of these because they could not keep patient monitors for the COVID patients because they did not know whether the COVID germs will still be there and all that. This was early COVID, where people did not understand what it was. So they just wanted to keep it there and throw it away. So yeah, it worked. I mean, we logged all the data to a flash drive and then they analyzed the data. So similar thing, we did one more in Africa, in some country that I cannot, I don't remember, I cannot pronounce, some newer country. So that was, those devices were somewhere in between this. Revision 5 is the latest one. And this is also on crowd supply. We changed it to, we still kept the name HealthyPi, and we used a Raspberry Pi RP2040 microcontroller instead of the older ones. Not just because of the name, but because it was just much easier to use and it was well supported. The latest one is called HealthyPi Move, which I will be talking about, which is a wearable form factor. So this is how we scaled HealthyPi. Purely through crowd supply campaigns because we wanted to remain open source. So this is the latest one. I mean, it's got pretty much the same functions that I mentioned. So the board contains, we had 2 chips on here. One was an RP2040 for the main controller, and We wanted to add wireless, so we had a separate ESP32C3, which ran the Bluetooth stack, and since we used Zephyr as the main operating system here, we were able to cleanly split the stack between these two. I will be going more into Zephyr in the coming slides. And those are some really high precision chips for SpO2 and ECG. These are the ones that are used in the medical grade patient monitors. So early on, we made the design decision not to use any chips that don't have a proper data sheet. Right? So there are a lot of them around also. So we ran into a lot of issues, and I'm going to. So finally, we ended up with 5.7, which is what is available right now. So as far as software is concerned, the initial GUIs for getting the signal were based on processing. But now, after that, something amazing happened because Flutter came. For those of you who don't know, Flutter is the Google's multi-platform framework, because we didn't want to develop app. We didn't get into app development because of the complexity involved, because of developing for Apple, and then people want for Android. Flutter was like magic. I mean, we just kind of were able to release this overnight. So now even our desktop GUIs are based on Flutter. We even have a web UI based on Flutter, and it's all exactly the same code base, and it's pretty amazing. So I just wanted to talk about why we made the HealthyPi Move, which is this watch that I'm wearing. I mean, it's not a watch; it's a patient monitor, right? So I'll talk about why we went this way, but before that, we decided, first of all, it has to have the same parameters or more than what the HealthyPi 5 had. These are the current specs of the one, but I will just go through each one. Yeah, so this is the why. The objective is the same, making medical devices accessible. That was the major objective. And why we went wearable is because wearable devices are more far more convenient for continuous monitoring. I mean, this is a feedback that we got from a lot of customers, and in fact, we made one small enclosure for putting this entire HealthyPi and making it wearable, but that was apparently not very convenient. So. And especially even for more serious applications like clinical trials. Some people were using this for clinical trials, drug trials, where after administration of a drug, then monitoring things like QT intervals, changes in PPG, and all that. One of the main problems these companies face is compliance, user compliance, because it's too clunky to wear, they don't use it. So what if it's a watch? And yeah, there are a few wearable digital devices. Some are really expensive for some reason that I do not know. And most of them don't interoperate with each other. So for example, even if you take a regular smartwatch, like let's say an Apple Watch or a Samsung watch, everything has to go through Apple's or Samsung server, and we don't know what is going there and what is coming back. They just give you a final report. So we decide to develop something that is this one is completely cloudless. Everything, all the processing happens on the device, and whatever processing cannot be done on the device is done on the GUI. And of course, smartwatches are cool. I don't use smartwatches regularly, but they're still cool. So some of the design objectives we had include all signals, as I spoke about. It should fit on the wrist. We were going to have only one single USB port for charging, because of the one watch that I had, I kept losing the charging dock, and we thought, why have that? And you can just charge it pretty much anywhere. If you are on a plane, just plug it in. And debug ports should be available, not just bootloaders, but low-level debug should be available. I mean, I'm sure the programmers would really appreciate that fact. Accessible from the outside, right? And this was a very important point. These are not sealed or stuck together. You can repair them, you can open them whenever you want, and it should be openable by screws, nothing that can break. Because if you've tried opening any of the smartwatches, because the only reason I've ever bought smartwatches is to open them and see. So it's really difficult without breaking something. And the same kind of sensors, no cheap chips. So prototyping, these are all the versions that we made, because we are new to wearable development, especially smartwatch development. So we tried a lot of different things. For prototyping, initially we thought, okay, let's go with the same design, RP2040. So one design goal, if you see here, I've stuck it out, saying that use the same microcontroller platform. But that later changed, and I will explain why. So we decided to use the same microcontroller platform as the HealthyPi 5, and we somehow managed to fit it. It's an RP2040 plus an NRF 32, which ran the same configuration. But yeah, we had a lot of other issues with this. The main one being power. It was taking a lot of power. So we moved to the 5340, Nordic NRF 5340. And UI, we initially had navigation wheels and buttons, because we did not want to add touch, because I mean, I just don't like touch on such a small device. That was just, but later we replaced it, because that's not what people wanted. So we decided on a round display, and there is a sensor board separately. So this was one of the first design. I mean, this was one of the final designs. So this was V2. V1 and V2 were based on Raspberry Pi, RP2040, and finally, after we made it into Nordic, this is what we had. But then the one struck out there is some stupid PCB mistake that we made, that USB port that you see there. Actually, we already made 10 of these. And then we realized that USB port that you see, the legs that go inside, we didn't give enough isolation on the inner layers, so that was shorting ground with the inner layers, and the device kept resetting. So we did not know that. We were wondering why is this resetting? And then we removed the USB port and everything started working. So we had to go to V6. So at this point, the design was pretty simple. One module, USB, and we put onboard flash. So because the HealthyPi 5 had storage capabilities on an SD card, here we did not want to put an SD card, so we put a NOR flash chip. So designs, we tried a 4-layer board and a 6-layer board on the right side. For the first time, we tried a 6-layer board, but then we thought, okay, that's not required, because we wanted it to keep it at 4 layers only. And this was a major change that we made. Power, again, so when we submitted this project to Crowd Supply, they said, okay, since you're using a Nordic chip, you can talk to the Nordic guys also and get their design inputs. And yeah, before I start, we were not forced by Nordic to use this. So initially we thought, okay, we'll just check it out just to keep them happy. But once we tried it, then we realized that this is pretty amazing. I mean, it's got all this stuff. which we earlier had as discrete components in different parts. One, it took up a lot of space. Second, we were wasting energy at every connection. So and we did not realize that, because every time you put a capacitor at the input and the output, and then you go to the next power component, you ended up losing a lot of energy, and our power consumption was at around, with the display turned off, it was at around, I mean, it's not optimized yet, but it was around 8 milliamps almost with the previous circuit, and at steady state. I mean, none of the devices were on sleep or anything. But once we replaced it with this one, everything became more integrated. It immediately dropped to 2.5 milliamps. And then we started removing more capacitors and finally optimized this. Now it takes about 2 milliamps. And once it is optimized, we are expecting it at a few microamps. So sensor boards. So I was talking about maintaining the same sensors that we had on the HealthyPi 5. So I mean, I won't go through this in detail, but we have, in the middle, we have a PPG sensor, which is an optical sensor that you've probably seen in every other smartwatch. But different from that smartwatch, which usually have, they usually have modules. This one is a discrete one, so we had to adjust the distances between the LEDs and everything to get a good signal. And there are 4 electrodes on the back. The center 2 ones are the ECG electrodes. I'll cover them in detail in the. So this is what the. I just copied Eagle things because it's just easier to show. So these are the bottom pads. So when we stacked it all up, and this is how it looks. So we have one PCB on the bottom and then a sensor board on top, and these two are soldered together. The rest are all board-to-board connectors. There's only one set of board-to-board connectors. It looks, maybe we should have taken this from a different angle, but it is quite a simple stack up. But we wanted a single stack up because it should be easy to assemble, and we wanted to stick to our objective of the right to repair. So coming to the sensors, the PPG I already explained is there is a photodiode in between, and there are 2 LEDs, and one can do red and IR together, switches between that. And but unlike other smartwatches, we also added a finger sensor. So if you're measuring PPG or SpO2, you definitely get a much better signal with higher confidence in the finger. This is pretty obvious because there are more blood vessels in the finger rather than on the wrist. And this also gave us an opportunity to add blood pressure by studying the shape of the BPG waveform. And we found it, I mean, it requires calibration, and then the calibration is good for the next 30 days for the same person. And this, the readings were quite close to an off-the-shelf blood pressure monitor, which was pretty amazing. So we still have both of the sensors. So the other one is connected through a cable, but if you can either use one of them or even both of them at the same time. I mean, if you really want to. So ECG is achieved by I told you there are 2 bottom pads. Actually, the bottom is just a PCB. Those are just gold pads. And there is one electrode on the side here. Because to get an ECG signal, you need 2 points, right? So this is the left arm and right arm. We also decided to add GSR because that is something which is easy to add on a smartwatch because you already have something on your thing. And so we have 2 electrodes. We inject a current and we measure the voltage on those 2 electrodes. I think I'm running over time, so I'll just go over this very quickly. One thing we're really proud of is that we have only one single USB port on our device, and that works as a universal thing. This is not part of the USB standard, but we kind of used a multiplexer inside. So one, of course, it can stream and charge data through the USB-C port. And the finger sensor, which is I2C. So when the finger sensor is inserted, it detects that, and I2C gets connected. And you can remove that. And also, one of our goals was to expose JTAG or SWD. So that is also accessible here. So I was going to go into more detail about how we did this, but this is mostly using the other pins that are there on the USB-C connector. They have lots of pins, and so we did it in a way so that we don't break compatibility with the USB standard, because most computers, especially Macs, are very sensitive to this thing. If it detects something out of spec, it just throws it off. But ours still works. The reason it still works is because the USB has a hidden mode called debug accessory mode, and we did not find out about it until very a little while ago. And what that does is, there are these RX to RX TX pins, which are used as high-speed lines when you connect a DisplayPort monitor or a high-speed, for example, PCIe over USB 3 and all those. Otherwise, it's never used. And the function of those is decided by these CC1 and CC2 lines, which some of you might recognize, but if you don't, I'll be happy to explain to you after the talk, because I'm already running out of time. So this is the final circuit, what it looked like. So there was a MOSFET which detected whether if USB is present, it goes to one mode. If VBus is not present, then it switches to something else. So we made an adapter board. So this plugs into the HealthyPi Move. This is a regular USB port, and this is how you can connect your. This is just a regular Nordic NRF development kit, which are pretty cheap. They're much cheaper than the Seger J-Link debugger, so it's about $50. And you can just run a cable from there to our board and just plug it in, and you have JTAG access while USB is also flowing. So it doesn't affect the D plus D minus lines. So I wanted to show that here because we are quite proud of it that we were able to pull it off, and it took a few revisions before we did this. So regarding enclosure design, I'm not great at it, but we just started. We used Autodesk Fusion, so we knew what the stack up looked like. So we kind of drew something around it, and I tried to add some nice curves and stuff, but this is not the final design. We are still working on the design. So we got an SLA printer and printed a lot of stuff and realized a lot of different things didn't go well, but finally we decided on this one. And this one works. This is the one that I'm wearing right now. Till now it's not, except one of the electrodes that fell off because it wasn't fitted properly. Everything else works fine. Quickly about the firmware is there somebody monitoring time? I don't think so, right? So I just keep talking until somebody comes in and kicks me out. So I'm just going to keep talking. This is interesting because our first versions were based on Arduino, and when HealthyPi 5 came around, we decided to switch over to. We started late, yeah. So switch over to Zephyr, and Zephyr is this amazing new. It's not new, but it's new to us. a new. It's not just an operating system, but it's a whole community. It's a whole ecosystem of drivers and kernel services. It almost feels like you're developing on Linux, but it is still a real-time operating system. So HealthyPi 5 supported both Arduino and Zephyr, but HealthyPi Move is purely based on Zephyr. So just a little bit about Zephyr. They have a great community. And this is kind of our code base right now. We have a single code base for both the HealthyPi 5, which runs on RP2040, and HealthyPi Move, which runs on NRF 5340. And everything else remains the same. I mean, except there are more drivers and stuff. And there are some few more boards that are coming up called HealthyPi EEG, which does EEG. And the only difference is you add more device tree files and configurations and more definitions. Zephyr takes care of the rest. It installs the tool chains and everything remains the same. Yeah, I'm over. Yeah.
By 20 minutes. So
I'm over by 20 minutes?
Yeah, it was supposed to finish, I think, yeah.
Okay.
Yeah, it's fine. Just wrap it.
Sure. So just a little bit more to come I wanted to cover, and a little bit about safety. We do basic safety testing as far as the basic standards are concerned. So, but this just says that, okay, it's not going to burn your hand, or it's not going to blow up on your hand. But regarding regulations, I mean, I added this slide because I get asked this question a lot. What about regulations? Regulations are left up to, I mean, we leave that up to the customer to figure out. I mean, if they are developing, depends on what they're developing this for. If it is a medical device, I mean, since that is one of the reasons why we do not really provide diagnosis results on this device, because once you get into diagnosis, it becomes a medical device, and then that is covered by not just FDA, but a different body in every country, and that can get really complicated. We went through that for one of our products, and it is really time consuming. So that's it. Thank you. And all our designs are open source. They're there in the GitHub. And yeah, you can email me or I'll be around. Thank you. Yeah, it is funding on crowd supply right now. Thanks for reminding me. It is funding on crowd supply right now, the HealthyPi Move. And we intend to ship out our first units by November, after a few more revisions of the design. So yeah, you can look up our crowd supply page. We are on the first page. Thank you.